This lesson is on points, lines, and planes. Let's look at these three terms. First, we have a point. It has no dimension and it is represented by a small dot. Usually we label this with a letter. I just could call this point A. Next, we have a line. It has one dimension. It's represented, like over here, as a straight line with two arrows on each end. The arrows symbolize that the line goes on forever and never stops. The two ways to label a line is either with a lowercase cursive letter. For instance, I could label this letter L. So I would call this line L. Another way is if there were points on the line, you would name two letters, and I could call this line AB. Next, we have a plane. It has two dimensions. It's represented by this shape. Usually looks like either a tabletop or maybe a sheet of paper. Like the line, it goes on forever. So even though you see these edges here, the plane extends infinitely. The way that we label a plane is usually in one of these corners you'll find a letter. In this case, I'll call this plane M. Now I'd like to point out something about the relationship between points, lines, and planes. In a line, you can have an infinite number of points, okay, because the lines go on forever. And for a plane, you can have an infinite number of lines and points. So that's something to take note of. Next, we have collinear points and coplanar points. When you see co, think of the word same. So collinear points are points that lie on the same line. So we would say that points A, B, and C are collinear. Now if I had a line drawn right here going through point C, and I labeled another point D right here, I can still say A, B, and C are collinear, but A and D are not collinear, and B and D are not collinear. But we could also say that C and D are collinear. Next, we have coplanar points. They are basically just points that lie on the same plane. Later I'll show you an example where points can potentially not be coplanar. Here we have line, line segment, and rays. Now we've already discussed line. The way that we would write line is you would use the two letters and put a symbol of a line with two arrows on each end. So for this, it would look exactly as it appears. For a line segment, the difference is it does not go on forever. Line segments have endpoints, which means they stop, and they also have a length to them. The way that we would symbolize a line segment is with just a bar above it. So this would be a line, this would be called line XY. This would be called line segment XY. Next we have a ray. A ray would also use two letters. Now the first letter is always the starting point. The second letter is the direction that the ray is going in. Since it's going in the direction Y, I wrote the letter Y second. So I would write an arrow like this. I'd like to point out that when we write the symbols for rays, we will never write anything like this. We'll never write this arrow going in an opposite direction. For instance, this would not be generally accepted. The arrows will always go from left to right. For this next one, Y is a starting point, so I'll write that as my first letter. X is the direction that this ray is going in, so I'll write that as the second letter, and again put the arrow above it. Next we have opposite rays. As the name implies, they're just rays that are going in opposite directions. So right here I could say that this is a ray if it started at B, and here's another ray that also started at B. So if I were to write the representation for this first ray on the left, my starting point is B, the direction letter is A, so I would write that as ray BA. My second ray, which was this one on the right, start at B, go in the direction of C. So I would say ray BA and ray BC are opposite rays. Finally, we have sketching intersections of lines and planes. We would define an intersection as two figures that have one or more points in common. This first example, we have a line that intersects a plane. So think of this as a sheet of paper, and you would stick a pencil right through a hole and it would come out the bottom. The intersection is right here. This is that one point that they have in common. Notice that the way that we draw this in geometry is anytime there's a part of the figure that goes behind another figure, we use dotted lines. So in this case, since we technically can't see through a sheet of paper all the time, this dotted line represents the part that is not visible. Next we have two planes that intersect. We have this red plane and this plane that's coming out. Again, you could see that it's dotted for this piece that's behind the red plane. The intersection that they would have is right here, this right here. Now since the definition says that they have one or more points in common, there is just an infinite number of points on this line segment right here. So that's why this is an intersection of two planes. While we're looking at this, I can show you an example of how 2 points can not be coplanar. So if I put a point here on the red plane and put a point here on this bottom plane, these 2 points are not coplanar because they are sitting on different planes.